Today we're going to focus on applications of linear equations. So applications, we're going to focus our linear equations as systems with two variables where both the equations are linear. And in each case, we're going to have to translate and solve, because we're going to be using word problems that we need to translate into a system of equations first before we're going to be able to solve using the techniques of substitution or elimination. So for our first example, let's look at the application. It says the sum of two numbers is 54. So that's the first sentence. Now this sentence will become also the first line or the first equation in our system. Also, their difference is 36. Let me make that a little. I want to find the numbers. And now that second line is going to be the second equation in our system. So let's go with this little bracket to start our system. And so we're talking about two numbers where first we want to be able to add them, and that's indicated by the word sum. So sum always means we want to add two numbers together. And so just create two variables that when you add them together is 54. And now it's saying their difference is 36. So difference always means that if we subtract those two numbers, we will get 36. And so when we're saying translate and solve, this is the translation. It's taking the various sentences in the equation or in the word problem and translating them to an equation. Now that I have my system, I'm going to use my addition elimination technique. So I'm just going to write that down. Right. And the reason I'm going to choose that is because my y values or y variables are already opposites of each other. And so when I add these two equations together, I'm going to get 2x equals 90. And when I divide by 2, x is 45. And so now if I think about this first equation, 45 plus some number is 54. And so that means that y is 9. So in this case, even though I chose the variables x and y, I'm not going to write my answer as an ordered pair. I'm just going to look at the two answers I have and just make a statement. The two numbers are 9 and 45. And that's how I'm going to write my answer today. It's just a statement of what is my solution to the equation as a sentence. So this is going to be our procedure for most of our examples, is that we're going to have to look to see how we're going to translate the sentences into an equation. So let's look at another that is a similar type to these problems, and that is the difference. The difference of two numbers is 12. Right, so difference of two numbers is 12. And then I'm going to do something a little different with this next one. I'm going to say 3 less than twice the smaller number. So 3 less than twice the smaller number is the larger number. And I want to find the numbers. Now this translation is a little bit different. The first sentence, very similar to what we've already done. Right? The difference of two numbers is 12. So again, my key word here is difference. And so if I take two numbers and I subtract, I get the value 12. Now because the value that comes out of my subtraction is positive, that means that x has to be my larger number. So x is the larger number. And that means that y is the smaller number. And I need that information so that way I can translate the next sentence. Right. The next sentence says 3 less than twice the smaller number is the larger number. And I've underlined that in the way that I want to translate my system. So the word is, this always indicates an equal sign. So if that is my equal sign, then what's on the right hand side is going to be the value of the larger number. And on the left hand side, I need to translate 3 less than twice the smaller. So less than, in this case, always indicates I need to do some subtraction. First, I need to know what twice the smaller number is. So if I know what twice the smaller number is, I need 3 less than that to equal the larger number. So this sentence says 3 less than twice the smaller number is the larger number. And that's going to be my translation for this line of the system. And now in this case, because I see an equation that says x equals, I'm going to use my substitution method. So I want to substitute. And I'm going to substitute all of this expression in for x. So that means that 2y minus 3 minus y equals 12. And again, this was my substitution of x. And when I combine my like terms, I get y equals 15. And then when I go and I substitute back into the first, I get 15 minus a number equals 12. And I can kind of just look to see what's going to happen here. I'm going to get y equals 3. Right? So when I write my two numbers, the two numbers are 3 and 15.